Okay, so this lesson we're gonna go over 7.2, triangle mid-segment theorem. So a mid-segment, first of all, you have to understand this definition here. A mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. So for instance, if I have a triangle, right? Let's say that this point right here is the midpoint. Let's say this is the midpoint. Let's say this is the midpoint of this side of my triangle. Now, let's say if we have another point, that's also the midpoint, but it's the midpoint of my other side of the triangle, this one right here. Now, if I go ahead and connect these 2 points, this is what I call a mid-segment. This is what the idea of a mid-segment is. Now we're going to learn about the triangle mid-segment theorems and its converse, okay? So here's the triangle mid-segment theorem. If a segment joins the two midpoints of the sides of the triangle, then the segment is parallel to the third side and it's half of the length. So basically what we're saying here, well, if we have this mid-segment right here, then these 2 lines here will be parallel, and also that this one right here will be 1/2 of the length of this length right here. This is basically the whole idea of the triangle mid-segment theorem. If you have a mid-segment connecting the 2 midpoints of the triangle, then your 2 lines will be parallel, and this line right here, the shorter line, will be 1/2 of the larger line. Or you can say that the larger line is twice the length of the shorter line. Now we also have the converse of this triangle mid-segment is also true. It's saying that if a segment connecting 2 sides of a triangle is parallel to the third side and half of the length, then that segment is going to be a mid-segment. So basically, without me telling you the length of DC, DE, DA, and EB, if I just tell you that I have this line that's parallel and this line is parallel, if I told you that these 2 lines are parallel, and I also told you that DE is 1/2 of AB, then you can just know through its converse that DC must be equal to AD and CE must equal to EB. It makes that DE is the mid-segment. Okay, so before we move on to actually solve problems using this, let me just prove to you why the triangle mid-segment theorem is true using what we have learned from previous. Now let me go ahead and draw a triangle out, okay? Okay, so we're given this triangle right here, and all we're given here, it says that we have an angle. We have a side. We have this. 2 sides are the same because we know that this is a midpoint right here. So this means that this side and this side must be the same because this whole line right here is being split in half. And same thing with the other side. We know that this side and this side must also be the same because this is a midpoint. So this whole line right here is split in half. Okay, now let me go ahead and label some of these so it'll be easier for me to refer to them. Now this is all we're given, and we're trying to prove 2 things. One, we're trying to prove that the segments are parallel, and also DE will be half of AB. Okay, now in order to prove this, let's go ahead and take a look, okay? Now if DC and DA are the same length, let me just call this length here X. They're both X here, okay? If CE and EB are the same length, let me just call this length Y. They're both Y because they are the same length. Now, using our idea of similarity and trying to prove that, we can tell that my smaller triangle here, let me go ahead and highlight it, my smaller triangle, the size of my smaller triangle is proportional to my sides of the larger triangle. Now, only the 2 sides I have, which is the X and the Y. And the reason why is because DC, let me go ahead and label it. Let me go ahead and draw. This is a smaller triangle, the larger triangle. Now, if I know here that my smaller triangle have one of the sides as X, and my larger triangle is 2 X's, right? Because I have this whole thing as my larger triangle. So it's 2X. And I also have my other side, Y, of my smaller triangle and 2y of my larger triangle because this was for the whole side. Now, if I can tell that these two sides are actually proportional, because if you go ahead and simplify, the x's cancel out, it leaves you with 1/2. The y's cancels out, it leaves you with 1/2. This means that they're both 1/2 equals 1/2, meaning that I have two proportional sides. So I have this side, and I have this side that are proportional. I also know the reflexive property that I have this angle right here as congruent as well, because this angle, it's the angle of the smaller triangle right here, and this angle of the larger triangle right here. They are the same angle, so therefore, through the reflexive property of congruence, I know that this triangle is congruent to itself. So now, I have a side that's proportional, another side that's proportional, and an angle that's congruent. This makes SAS similarity, which proves that my two triangles, the smaller one and the larger one, are proportional. Okay? Not proportional, I mean, they're the smaller and the larger triangle, they are not only proportional, but they are similar. Okay? Now, using the idea of similarity, it'll be easy to figure out why and how can we prove that both lines are parallel and both lines, one of the lines is half the length of the other. Okay? Now, using the idea that two triangles are similar, similar triangles have the same angle. So this means whatever angles right here must be the same angles right here, right? If these are the same angle, then this means that my line right here, actually right here and right here will be parallel because they are having the same angle. Okay, so this means that this right here and this right here will be parallel. So that proves the parallelness. Okay. Okay. Now the second part, to prove that my DE is going to be half of the length of AB, it will be easier as well. We have figured out that previously that my proportions of my smaller triangle to my larger triangle, or my larger triangle to my smaller triangle, is 1/2. Basically, the small triangles is 1, the large triangles is 2. So if I just call this length of DE, let me just call it Z, okay? If this DE is Z, then according to my proportions that I found previously, they must stay proportional because they are similar triangles. Then I can be for sure to tell that this length of AB will be 2Z, okay? Now, I have proof, using my idea of similar triangles, that yes, this triangle mixed segment theorem is definitely true, okay? Now, the converse of the triangle mixed segment theorem will also be proved in a similar way, but I will not show it in this video, okay? Now, let's move on to the next page to practice using triangle mixed segment theorem and its converse.